log of the data and I made my graph and I cheated. I had Excel calculate the slope for me and see. So can you write that equation down? Whoops. The slope. Oh, you're not happy. Okay. Can you write this down? This is x1, y1. So, what is the x1 here? It's 0. So can you write down 0, comma, and what's the y1? About 6.2. So write down 0, comma, 6.2. Got that? Now, look here. What's the x2? 900. And what's the y2? 4.6 about. 4.6. So can you write that down? 900 and 4.6. Okay. So Hareen, what was the first point? Did I say 0?
0 and
6.2. And the second point? 900.
Yeah, 900.
Yeah.
And I forgot that one.
Did you not write it down?
I know how to find it.
4.6. Right. So the slope is y2 minus y1 over x2 minus x1. So that is minus 0.0017. Now, the real answer, hey, that's not so bad. 0.0017. Not too bad. Okay, so now do you understand what this number is? Okay. Okay, so, right, now I know yesterday we had a little bit of trouble with the units because I kind of screwed it up. Well, not that I screwed it up, but I don't think I made it clear. So please look carefully. So you know that the slope, what did we say yesterday? That minus 1 over the time constant, yeah, is the slope. Isn't that what we said yesterday? Wasn't it? It was. No, that doesn't feel right.
You did. No, wait, let me check that out.
Yeah, that's what I said. Yeah. I said time constant is minus 1 over the slope.
T equals minus 1 over the...
Not T, tau.
Tau?
Yes,
So...
Sorry.
So you could also say that minus 1 over tau equals the slope. Yeah? Now what units do we use on the voltage? It should be volts. So if you want to be extra careful with your units, let's type in what the slope is. It was log, look, please look. It was log, I need me confused. Okay, I'll do the X one first. 900 milliseconds minus 0 milliseconds. Now, how did I get the 4.6? That was log 105 was 4.6. So this was log 105 microvolts minus log 500 microvolts.
Can you just use your values instead of writing log?
Oh no, I'm doing it this way to be really clear about what the units are. So I'm going over the top. Now this is the nice thing about logs. When I minus them, that's the same as dividing. Now this is really, really, really good, because what happens to the micros?
Gone.
They cancel.
The vault of the cancel.
Yeah, but I mean, that's my point. You don't care about the units for the voltage. So you're just left with, in the denominator, 900 milliseconds. So I hope this makes it clear. What's the unit for the time here? The time constant? Milliseconds. So you see this slope here, we're using milliseconds. So the time constant is minus 1 over 0.0017 milliseconds. So let's get that. That is 562.5 milliseconds. Or if you want, that's not 2. 562.5 milliseconds. Or 0.563 seconds. So here's my little hint for the units with the slope. I'll go back down here. This here on the top, great. No units. This one in here has the time units. So microvolt, millivolt, gigavolt, don't care. You only care about what happens with the time. Because of the logs, it means the units will cancel. So it doesn't matter it was microvolts, gigavolts, millivolts. Doesn't matter. You only care about the time one. Which means I think I might have made a mistake yesterday when I said the time was seconds and the millis cancel. Did I say that yesterday? Well, that was a bad Stephen. So in yesterday's notebook, if you go back to yesterday's class or the last class, where's the last class? Where I did the table. This one here. Where's my time? I said milliseconds? Oh, that's right.
Oh yeah, you did say milliseconds.
I did say milliseconds. No, that's right. That's right. Okay, cool.
You're talking about this one, right?
I like it when I thought I was wrong, but I was right. Yes. Okay, what's the next question? After the time constant.
How long until this capacitor fully discharges?
Okay, so what's the time for that?
Ask you something.
Anybody remember how to get this one? The time to fully discharge? 5 taus. So that will be 2.815 seconds. Okay, is there another part?
Yes. When will the voltage be 80 microvolts?
Okay, so you want 80 micro.
No, he missed the question.
Oh, what?
What was the value of the resistor?
Okay, so you have what is this? Goodness, what's the formula? RC equals time constant, wasn't that it? Yeah. So do we know the time constant? Yes. Do we know the C? I think I give it to you, don't I?
Yes, 100 millifarad in the question starting.
Okay, 100 milli. So the resistance is about 2. Sorry, 5.63 ohms. And then the last part is, when is the voltage going to be?
8 volts.
Okay. So what's the voltage at the start?
It's
500.
500
Micro.
microvolts. And what voltage do we want?
80.
80 microvolts. And what's the time constant? 0.563. You've done this with Roland. You know, this cancels with this. I can bring the 500 under. How do I cancel E?
Log.
So I can put a log here. Log 80 divided by 500. So you get minus 1.833 equals minus T over 0.563. So there you go. T is 3.26 seconds.
Can you make this work? No, it's okay.
Sorry, which part was that now? Is that part D?
Yeah.
E.
Is
So this one was D.
it's D.
This was the last part.
Well, the voltage, yes, D. No, is it yes? No, yes. I don't know.
Yes or no?
Is it the last part of the question?
No, there's another three. There's F, G, and H.
Oh, there is?
Yeah.
Alright, okay. Well, anyways, can we go to the next part?
Yes.
No. Sorry, this is one part here, and then this is another part. So what part am I doing now?
It's E.
E, okay. So this was D.
Yeah.
So this was C. Okay. Huh? What's F, Harim?
What is
How much charge is the capacitor holding when a volt meter reads 80 microvolt?
So Q equals Q0 E minus T over tau. Do we know the charge at the start? No.
No.
But you have this formula. Q equals CV.
yeah, we have capacitance
And you have have them.
voltage,
Yeah.
Is it the voltage 500 you're starting?
Yes. So because you know Q equals CV, you can change this into C V0 E minus T over tau. Do you know the time and the time constant? You do. You know all of these, don't you?
Yes.
What's the capacitance? 100
milli.
milli. And what's the voltage at the start? 500 micro. And what's the time? 3.26, and the time constant 0.563.
But you know, it is saying voltage at 80 microvolts, so I think we should use.
Yeah, but that 80 micro was the last question. We know the time when that happens.
Yeah, we got the time.
Yeah, we got the time. I got here 0.0162 coulombs. Or if you want, that is 16.2 millicoulombs. Okay. And what's G now?
What is the voltage after 1200 milliseconds?
G. What's the voltage after 1200 milliseconds? Okay, so V equals V0 E minus 1200. That's 1.2, isn't it? 1200. 1.2 over 0.563. The voltage at the start was 500, wasn't it? Quite small. It is 59.3 microvolts. Did I give you one or two questions?
There is one more.
Was it long as well?
No, it's more.
You said it's short.
Did I? And you believe me?
Of course not.
Good. Show me it. Let's see the second one, how big it is.
This one?
No.
It's not yet.
Have you got it?
But we have a last part too here. What's the current part?
No, no. This is the homework, isn't it?
Yeah.
Yeah, there's only one more part, yeah.
It's one more part, no.
Yeah.
No,
this one.
yeah. What is the current after this time?
Yeah.
Okay.
Plug in.
Yeah.
In f e to the minus t.
Yeah.
The formula, but let's do minus.
Oh.
I forgot my minus. I hope I typed minus. Maybe I didn't. Thank you, Sohi. You saved the day. Let's see. Minus 3.26 over 0.563. Yes. Okay. Thank you, Sohi. That should be a different number. It's going to be very small. 0.153 microcoulombs. Okay, and the last part there, Patrick, was what's the current?
Current, yeah.
Okay. Now, current, that's the same, I0 e minus t over tau. But we should maybe use our formulas. You know, VIR? What does I equal?
V over R.
Yeah, so I think it'd be smarter to say the current at 1200 milliseconds equals, if I have my VIR triangle, equals the voltage at 1200 milliseconds divided by the resistance. So that would be 59.3 microvolts divided by, what was the resistance we got earlier? 5.63 ohms. So here I get 10.53 microamps. Yeah. Yes. You can do this.
Are we going to have me?
Of course. We have 2 classes today.
Then, in knowledge, is that you are going to have the same question?
Oh yeah, I forgot. Maybe I can do it next time. I forgot to bring the exam. I forgot. Yes, who's this going to be? Who could this possibly be? You're totally lost. Or totally early. But you're an hour early. I think you're not here till 12. No, I think it. We have 2 hours now, don't we?
Yeah.
Yeah, no.
You're like 1 hour early. Look at the canteen or something. Okay, is that okay, Grace, or do you really want me to do the exam now?
No, doesn't matter.
No, seriously.
I want to know what I got.
Oh, did you not see Carl yet?
No.
Oh. Hang on, I just want to check what the next topic is and then I'll decide.
Oh, Kirchhoff.
You remember Kirchhoff? You like Kirchhoff?
I don't like
You do like Kirchhoff.
Like Newton, I don't like Newton.
It's Kirchhoff.
After class, you're gonna go to Kirchhoff.
Hang on, let me think. So we have 4 topics left to do in electricity. Is this our last physics class this week?
Yeah.
Okay. Now, next week you have your active listening thing.
Yeah.
So you might lose the physics class. I don't know when it'll be. So we'll have 3. You have 2 weeks after this before your holiday?
You have holiday?
Easter holiday, no?
What is Easter holiday?
When is your exams?
I don't know. What is
I
that?
think it's 9
Listening?
April.
First week of,
April.
no,
I
of
think
May.
it's 9
April?
Yeah.
Wait, hang on, this is March, isn't it?
Yeah.
Hang on, don't confuse me. So we have, how many weeks of school left?
15 of
Two
2 weeks?
before holiday.
Then holiday and then exam?
Yeah.
Ah, no, I need to try and continue, and then what we could do is, you know, the week before the exam you don't have EAP classes. Maybe I can take some EAP time and we can do some physics revision of the mid-semester and exam questions. But I would like to do Kirchhoff today. I know this will make you happy. I know it will, okay? So let's